Okay, everybody. Um, Thanks for being patient with all this. And as we go through this, hopefully this will be pretty interesting for you. This is an area that I tend to find really interesting, and hopefully you guys will as well. If there are some brief says that could be that I had to mute myself to cough or something. So if you're listening to this and you're thinking that it froze or something, it might not have. So, okay, human error, and then we're gonna do a little bit on human error and design. That'll probably be the next lecture a little bit more. What I found is, so this is 40 slides or so. If I go much bigger than this, it really tends to struggle when I upload to YouTube. I'm not sure why. So I'll break it up a little bit. And that's better too. I don't want you guys to have like a 3-hour lecture to video to have to run through. Okay. So we'll start going through the Slack and some of those. So yeah, like I said on the Slack a couple times, I am finally getting better from what I'm calling the bronchitis of death that stormed through our house. Well, obviously that's supposed to be from, not form. Already winning. So yeah, my youngest daughter, who is patient zero, is great. My wife and I are still struggling through this. So yeah, it's been touch and go and a bit of an experience. Midterm stuff, I haven't had a chance to read through all of them yet, but so far, like what you guys have done, I think it thing I just want to tell people is just not try not to stress out about it, have fun with it, learn something, and explore different ideas. I think everybody is almost is up now, so just keep commenting on those if you have another idea or point on something. If there's something that you want to bring up on your own, let's say there's a topic that you fleshed out, but maybe you thought, hey, I could have done this better. I'm not really sure on these things. Bring it up to all of us and we can kind of talk about that. But all in all, I think we did good. Going through the Slack, it was interesting, Nathan, to see about the nuclear powered airplanes. I've heard about those before. I am not certain if those engines are on site. Um, I mean, I guess it's possible. There's a lot of things that are stored out here. But when you're down here, I can reach out to some people and see if I can find them. There are actually pieces of 3 Mile Island, the meltdown, that are still here too. So it I don't know, it might be in a place that we're not allowed uh to use it or to not to use it to access it. So we'll have to see. Luke, I'm glad you did the VR thing. VR is going to be an interesting angle of research in nuclear going forward for the next little while. I think that'll be um, kind of a unique thing to look at. Especially when we get to these. One of the common applications I think of is maintenance staff. So especially in these plants, these nuclear power plants that are 40, 50, 60 years old, there's often 3, 4, 5 different naming conventions that have happened throughout the facility. So if any of you ever come out here to INL, for example, and you do a tour and you go out to ATR or the Advanced Test Reactor complex, all the buildings say TRA because it used to be called Test Reactor Advanced. And so you get those in these plants. So sometimes, what if you had a procedure that refers to a pump in a different way than this person's used to or something, and they have to try to find it? AR would be an interesting solution for that. You've got people walking through the plant. They know they have to execute this maintenance task. And so they almost have like a GPS to a geolocated pump that is identified as the right one. I don't think there's a ton of instances of people taking apart the wrong things, but I'm sure it's happened. That's an interesting experience. And looking at like multimodal interfaces in general, VR, AR, auditory, so like Siri, Alexa, voice interfaces is a weird one in nuclear. I'm glad everybody found or I guess Nathan found the shared drive, or I had to delete them and re-add them, I think. If any of you don't have access to that OneDrive, let me know. Yeah, I commented on this about Mary with the font recommendation. So yeah, I think he published it, but you can look up some work from Casey Kovesti, Kovesdi. He's one of my coworkers at the INL. He had done some font and specific color work a few years ago, I think, and published some stuff on it. So he's kind of our resident expert for those kind of things. At least here at INL. And he also I remember Newreg 0700, which is kind of like the big nuclear like style guide thing. When that came out for review, the new revision, I know there were some font questions that he had, some concerns or edits that he wanted. I can't remember any follow up them on if those made it in or not. Yeah, this post by Luke, if everybody could comment on this one. This is interesting. It's one of those things to think about. Like, we all have things that we don't want to interact with because the interactions suck or whatever. Nathan commented on the Final Fantasy 13 mapping system. I actually didn't play 13. If it lands on Xbox Game Pass, I'll plan on playing it soon. For some reason, it's just, I skipped it. I don't remember what was going on in my life at the time, but I just didn't play it. But that does sound like an abomination of a map function. My most hated map is the Fallout, just in general. I'm not crazy about Bethesda games anyway, but the Fallout map, I know it's supposed to be stylized retro computer Windows 3.1 stuff, but it's just impossible to tell verticality or any of that stuff. And it's really frustrating. Hulu's user interface does suck. I think one of the things that's hard, and Disney Plus is odd. It is missing some like seemingly obvious things, like play from beginning and those kind of things. It's just kind of strange how it does that, and how the fact that you have to so if you're not on the top few tiles, you can't get the pop-out menu now below, and you try to scroll to the left, you won't get the search bar or something. So I hope they fix it. They probably won't, because Disney, I mean, what motivation do they have to fix it, right? They are huge now, and that service has been extremely successful in the way it is. So it's just like Netflix, right? Netflix's autoplay was a problem for years, and they just didn't care because people kept signing up. So, but the Hulu's is bad too. I think streaming services in general, if any of you ever want to do like a weird interaction design project or exploration task, that would be streaming services would be really, really interesting. It's not necessarily that the services have to be or have some constraints on them that make it hard to use. It's more the remote, right? So your vector for interacting with it is different and is limited by design. So how does that work? How would you have an interface, let's say, that works with just like a Kindle Fire Stick remote that's got 8 buttons on it, as well as like a Harmony Logitech touchscreen remote. But yeah, the interaction design of streaming services is definitely a struggle. And I think it's hard for them too, because it has to be multimodal also by design, because you have to have a similar interface for iPads as computers, as TVs. So that's definitely a problem. And then I'm sure I can think of a ton. There's not very many things I like doing when it comes to computers in general. And then, okay, going through, let's see. Oh, the D20 thing on my wall. I think you're talking about the wood cutout. That's a laser wood carving that my wife got me for my birthday or Father's Day, one of the past few years. I played Dungeons and Dragons since I was 13, so it's a pretty big thing for me. Um, and then moisturizer. I don't know. That's funny. I hope I'm not looking all ashy on the stream. That's no good. But I don't know. My daughter and my wife have eczema at different times, so we've found good use for the Eucerin fancy ones. Okay, so for the final, I have some different ideas, and I guess if you have any thoughts or things, ideas about these recommendations, let me know. Post them in the Slack, whatever. So I initially wanted to, I was going to randomly assign each of you one of the topics that your classmates did. So like hypothetically, you know, Mary might get VR nuclear training. And then let's see. Okay, sorry about that. Calling me. So anyway, ideas for the final. So yeah, I had thought about that. So assigning like everybody else that, and then your final would actually be probably less work than the midterm, because I would probably just say everybody just do like, so assume my idea, you got handed, this is a project we're going to work on, give us the pros, cons, opportunities, challenges, those kind of things around this idea. And so I don't know if it'll work totally for everybody's. I haven't been through everybody's yet, but that was one of my ideas. We could also just kind of do a redux of the midterm where you guys pick a different topic and do maybe a shorter, more brief kind of 1 page or 2 pager on what it is and what's useful for it. You could, I know it's got brought up a few times about a task analysis. If somebody wants to actually do a task analysis because you've never done one or whatever, and you have a, you know, potent need to do one, I guess, or urge, then let me know and we can figure something out. Task analyses can become huge amounts of work, and I don't want that to happen to any of you. So let me know if that is something you want to do as soon as possible, and we'll figure out a task, either a section of a task or something, so you guys can do that. So yeah, just kind of let me know what you're thinking, what might be valuable to you in, you know, just your learning, or if you're trying to come up with a portfolio or build some specific tasks, or not tasks, some specific competencies. But we only have 4 weeks, so we'll figure something out. I think it'll be good. Okay, so now we're what human error actually is. So I have some different takes on some of this than other folks, but I just wanted you guys to kind of think about these things. So, what is human error? So, James Reason said it's a generic term to encompass all those occasions in which a planned sequence of mental or that's supposed to be or physical activities. That's what happens when I type while I'm on medication, I think. I don't know. Or physical activities fails to achieve its intended outcome, and when these failures cannot be attributed to the intervention of some chance agency. Okay, so this definition seems to be outcome dependent. So if you totally make a human error in terms of you do the wrong thing or something, but nothing bad happens, or through some weird instance you happen to still achieve your intended outcome, is it an error? That's one of the question. I think chance agency is funny here, that it's just a weird, okay, what's that even mean? Is this like a Descartes evil demon situation or something? Um, and then planned is doing a lot of heavy lifting here. So a planned sequence of mental or physical activities. I want you guys to kind of think about, when you think about the things you do just throughout your day, how many of those things would you say are planned versus automatic or different things there? And then there's a YouTube clip here. If you guys want to, I'm going to pull it up. That's what I was going to do. So I'm going to play this for you guys. I'm going to have to stop sharing for a second and switch around how I'm sharing it. And then that will work. I'm going to just share that desktop. Okay. So this is an interesting question. This is one of my favorite sports moments of all time. And so I hope you guys enjoy it as well, because it was just so funny when it happened. And actually it's happened a few times, which is odd. It makes you wonder like about like just the sporadicness of life. So this is an interesting thing. Was there an error made at this point? Is my question for you guys. So um was there an error made by Randy Johnson or possibly a bird? Who knows? But this is a real instance. This thing did happen. Um, so you guys can listen to this. So if you watch so Randy Johnson, one of the best pitchers ever and who threw incredibly fast, just so happened to hit a bird mid pitch, and the bird essentially was demolished. So that's a question, right? Is that an error? How does that work? Um, that's not what I wanted to do. There we go. So think about these things with human error. It's very rarely that simple. So here's my next question that I always run into. Can you intentionally make an error? So my argument's always been an error is fundamentally unintentional, because if you meant to do it, then we would call it malicious compliance or sabotage or whatever. So if it's unintentional completely, how do we know that we actually made an error? Well, probably system feedback, feedback from the world, something like that. Now, the next question is what's really important for human error research and the other kind of usability or human reliability analysis, all the other things. How can we know why we made an unintentional error? So if something was unintentional, you did not intend to do it, how then can you explain why you did it? And this is one of those really difficult things that I always latched onto. Now we have to do research on this. Like we know there are human errors. We know we have some semblance of access to our innermost thoughts and decisions. So how can we process that in a way that's gets us to a real answer? But that's a big problem. It's also a huge problem when it comes into studying this. And some of you from the psych side might be really, really sensitive to this. How do you design an experiment that can consistently elicit an unintentional, erroneous action in such a way that it gives you information about its cause? That is a hard problem to solve from an experimental design. So that's one of the things that we try to work on and figure out. But it's important to kind of consider this. We kind of take human error for granted because we've all made mistakes or whatever. But what does it really mean? Because in a sense of like nuclear, right? When there is a mistake, we need to know why it happened so we can avoid it happening. But it's like with kids. If you've ever asked, if you have a kid and they do something ridiculous and you say, hey, why'd you do that? And they say, I don't know. That's honest. Adults have to try to make sense of things though, and that's still a problem. So if it's inevitable that some amount of human error is always going to occur, what do we do? So there's two paths, primarily in nuclear, that handle this. Human factors. So this is design, evaluation. How do we kind of manipulate or rebuild these systems so that they're more effective for humans? And human reliability or human reliability analysis, really a risk assessment technique to try to get at the likelihood of human error given various circumstances. This is an important question, right? We think about this, especially if any of you do work in cybersecurity, right? The key is to get humans out of the loop. We don't want humans doing things. Um, so what about automation technology in, in relation to human error, right? Like, will it save us? Will it help us? And anybody who's ever done IT work will have this cartoon will strike pretty true. Like humans do weird things and they break things in ways you never could have expected. So what that means though is usability testing robust testing with users who will use your product, won't use your product. Anybody you can get is important because they'll give you more information about the vulnerabilities that your software has or your product has to humans. Human error and risk kind of in general, right? So percent of incidents where human error was determined to be a root cause. This came from a 1994 study. So on C, human errors appears to be a big problem. Same with the chemical industry. Airline and commercial nuclear have tails of that, but that's still a 20% range. Like that's come on, guys. That's pretty ridiculous. That's you're including your like oh my gosh, I wanted to say externality, but that's not right. You're including your deviation. No, that's not right either. Anyway, you're including the things that are too far extreme outside of your standard deviations and your normal range to make that look better, I think. And medical error is a huge one. If any of you have any interest in medical error, medical human factors is becoming a hot field, and so there's a lot of work there. And it's also incredibly important because there are a lot of deaths and injuries every year because of medical error. But for some reason, doctors still believe that everybody should work 15-hour shifts or whatever. It's ridiculous. So there's problems there. So this is an interesting question. Can human error even be a root cause? This is an important question. So, and for those of you not familiar with root cause analysis is an event investigation technique where something happens, so you try to figure out what was the root cause, what was the one thing that if it was fixed or if it didn't occur, nothing else in the chain would have happened. And there's different opinions on this, I guess, probably depending on what you are invested in terms of which section of the system you think should be the cause. But the person who trained me on root cause analysis said, if human error is your root cause, you didn't go deep enough. And it's important to remember, so that first quote from Don Norman, there's no human error, just bad design. The second bullet there is kind of my argument from the previous slides. If humans don't intentionally err and error occurs, how can we attribute that to the human? How isn't it that the circumstances were such that error was more likely? So this is something you'll see. So when we go back to this slide, right, that's my response to all these numbers is, no, there was something else. There was a design flaw or something that no one wanted to handle because it meant that they had to reinvest in something, is my guess. But that's a different take on that. And I could be wrong. So things to know about human error. It's reliant on human cognition, obviously. Every human action is subject to imperfection. Most research has shown that even highly trained, highly skilled actions like those of a nuclear power plant operator tend to fail 1 out of every 100 or 1,000 times. Factors may increase or decrease that likelihood of error. So that's what we would call, we'll get into these later, performance shaping factors. The same qualities that make human actions error prone also afford resilience. It's one of the weird paradoxes of humanity. We do things kind of impulsively sometimes, but we can also be we can be very creative in the way we err. We can also be very creative in the way we solve solutions. We're also incredibly competent at spontaneous recovery and interacting with our external environment and that feedback loop. Humans are really, really good with those things. This next slide here, I'll try to distill this down, but this is one of my favorite quotes about human cognition. So at the level of perceptual analysis of raw sensory inputs, man evinces a remarkable ability to integrate the responses of a vast number of receptive elements according to exceedingly complex nonlinear rules. Yet, once the profusion and welter of this raw input has been thus reduced to a set of usefully invariant conceptual objects, properties, and attributes, there's little evidence that they can be juggled and recombined with anything like this facility. So what Shep is saying here is We are incredible pattern matchers, and we can identify very slight patterns. That's how we can identify issues in a feedback loop and adjust. However, once our brain distills all those elements into, objects, properties, attributes, the things that make up our memories about the world, those chunks, we are not very good at putting it all back together and then making a decision from that. It's kind of a weird instance. So, and it makes human error research very difficult. So human error taxonomies, there are three big ones that you can rely on generally. So there's Swain and Gutman's human error taxonomy, which mainly gives us, we'll go into it in a little bit, but it gives us error types, and it came from THRP, which is a human reliability analysis technique. Jens Rasmussen's skill rule knowledge framework. So actions tend to fit into specific bins of cognitive performance. And James Reason's error taxonomy / Norman's action theory, which is slips, lapses, and mistakes. I give them both credit because I'm not totally sure which came first. They came out very closely in time, and realistically, it was probably Norman. But depending on who you ask, they might say these are Reason's things or Norman's things. But just so you know, they kind of both have the similar ideas. And Gutman's, so yeah, it's proposed in THRP, which is nature A method. And it gave us this delineation for errors. So error of omission is when you do not do something that you should have done. Error of commission is when you do something you should not have done. Sequential errors, so if you're following a procedure and you do step 5 before 2, or timing errors, which are doing things too slowly and too quickly. What's important, an important historical thing, if you go and you look at THRP as and its original write-up, it has some tables on human error probabilities and those kind of things. It's important to note those are the only HRA, or one of the only HRA error probabilities that were ever like measured. Everything else is usually derived from expert evaluations or in some instance from THRP. But what's important to realize is the THRP error research was done in nuclear weapons construction and assembly. So it's also, this back in like the 70s too, 60s, 70s. So very old. So digitization has no role to play there. So if you're trying to do anything digital, the THRP HRA tables just aren't applicable. And it's important to just hey, this was done in a task that was very risky at a time, and that's just an interesting thing about that. I think Gutman might have passed away. I believe Alan Swain is still alive. So going to Jens Rasmussen's skill rule knowledge framework, essentially all of our actions can either be skill-based, rule-based, or knowledge-based. And the probability of error increases as you go from skill to rule and from rule to knowledge. So skill-based, we're talking automatic activities, turning a doorknob, depending on, I guess, your hygiene, brushing your teeth, like, or flossing. I've never quite got the hang of flossing, but some people are just wizards at it. Rule-based is when you have to actively engage either physically with the procedure or mentally rule or procedures that can help you govern your actions. My daughter has some autism spectrum challenges. She has some, what we would consider skill-based, rule-based for her, because she just has to think about how to operate in different situations. I don't know if you guys can see my internet connection. I don't know how that's even possible, but it is. Knowledge-based. So this is when you have to engage. This is problem and decision making and things like that. You want your users to spend as little time as possible in knowledge base, because that's where the highest source of error is, or so Rasmussen's pointed out. So here's just an attention and familiarity matrix that can show you, kind of how those three kind of play in terms of um, related to how familiar you are with the task or attention. So obviously, if your familiarity is low, your attention should be high because you have to really pay attention to figure out what you're doing. And then this quote on the right there probably made sense more on the automation page, but how can machines be devoid of human error if they're built by humans? That's also an important automation thing we'll get into maybe in a few weeks. So Reason and Norman's error taxonomy. I tend to prefer this one over the others. It's not like you have to pick one club, but I tend to prefer these. So slips are when you mean to do the right thing, your mental model is accurate, but you happen to do it wrong. You just hit the wrong button, or you turn the switch the wrong way, or whatever. So it's an error of commission because you do something wrong, but everything else was right. Lapses are the error of omission. You meant to do it, you had the right perception, but you didn't do it for whatever reason. Mistakes are when you intend to do the right thing, but your mental model is wrong. So I meant to do this, but my understanding of the situation or the environment or the system was false. Therefore, my performance was bad. Violations are willful circumvention. It's not always malicious or sabotage, but it can be, he calls them heroism, or the mentality of there's a better way to do something, like, oh, we don't do that procedure step because it doesn't work. So we actually do this, this, and this. Um, it's a separate kind of instance there, right? So you still have an intention. Is it a good intention? Possibly. It kind of blows up the good intention mental model action breakdown, but it's still a really important thing, especially as you get to aging systems, and that there's a lot of shortcuts or weird little quirks that people have learned to get something to perform well. So the taxonomies, these are kind of the breakdowns of what we use them for, or what they give us. The HAZOP, if you've never heard that before, that's a kind of a nuclear or industrial term, stands for hazardous operations. It's a safety kind of philosophy or set of principles. You can find tons of information on HAZOP if you're interested. But so if you have a system or a risk situation where HAZOP is an important characteristic, or it's being done in accordance with that method, then Swain and Gutman's will give you some of the things that you will need for that. Rasmussen's is interesting, especially when you consider automaticity. So the skill-based aspects, right? And then Reason's taxonomy gives us the intentionality. So it's really important to look at all of them. It's cognitive mechanisms of human error. This new reg is a tome. It is like 500 pages or something, but if you're interested, it goes into kind of different aspects of cognition and their breakdowns for human reliability analysis and therefore human error. Can be interesting. It breaks down these units of these macro cognitive functions. So detecting and noticing, sense making and understanding, decision making, action, and teamwork. And then it'll talk a little bit about how those can each break down. So it could potentially, you could explore that as like a different way of understanding how we perform actions. It's an interesting text for sure. It has some good information in it. These are the other ones, right? So memory issues, attentional constraint, vigilance, and boredom is a huge challenge. Getting people to pay attention to boring things is a huge source of cognitive strain. Lack of experience or too much experience can even be a problem. The keyhole effect. So this is you only see what you can see. You know, oh, why did an alarm go off? Weird. You have so that saying, you can see the forest for the trees. This is I would love to see the forest, but I'm looking through a tiny hole and all I can see is a tree. That type of cognitive aspect is something that we all deal with. It's very, very difficult for humans to see what we would call the big picture. Heuristics and biases are big, big problems in cognition and decision making generally, and confusion. Sometimes it's just you're not sure, or there's, especially in a complex system like nuclear, right? There is so many variables that can jump up you might not have experienced it. And I love this little meme. It always made me laugh so much. So you get a window that pops up that detected your monitor's not plugged in. Well, how is it going to tell you that if you can't see it? It's funny. We'll probably get through a few more slides and then I'll wrap this one up. So the Swiss cheese model, you'll hear this a lot. It's also defense in depth. So defense in depth means you put a bunch of things as defenses against an error. Cheese model is error will occur when all of the holes line up. So the sun, the moon, the stars align, therefore this happens. What's interesting with industrial accidents, that really does seem to be what happens. There are latent issues or underlying problems, and then over time, it just so happens that they become more problematic and more prevalent in your just kind of daily life, and then therefore those holes become bigger. Now, this is kind of sometimes it's hard to kind of extrapolate what the Swiss cheese model means. So now that we're all in COVID life, this is a good example that I like. So defense in depth are all these different things that we were recommended to do to prevent spread. The hope is if we do all of them, at some point that transmission is going to be stopped, because it's highly unlikely that the holes will line up on this many, on such a high number of defenses is the idea. So hopefully that'll help kind of clarify that point. Like I said, the Swiss cheese model can become kind of problematic at different times. So looking at different error consequences. So, the difference between nuisance, damage, and injury. This is something you'll hear about sometimes in the potential result matters, as does recovery opportunities. So it's important. This is when we get into like designing for error, which we'll get into a little bit more. And I just had to call out blunder. I don't, it's like one of these things is not like the other. I don't know who made this chart, but I love it. And I love that they put blunder in there. I really wish that all of these were that way. I want, ballyhoo and kerfuffle in here, but either way, I don't get a tier list of errors, I guess. So now going into, let's see the time. Yeah, we'll wrap up this slide, nuclear specific terminology. So I'll leave you guys with this. So human error, according to New Reg 1880, which is a PRA document, the human error is human caused failures of systems or components. But in behavioral sciences, the same term is used to describe the underlying psychological failures that may cause the human action that fails the equipment. So it kind of depends on your angle there. A lot of the engineers will think, okay, the humans made an error, therefore this pump failed. They don't really care about what happened before the human acted. We do, because we're trying to figure out why did the human do something that led to these problems. Again, going back to that initial thing, if humans don't intentionally make mistakes, what led to the mistake? ASME has a different description that exceeds some limit of acceptability, including an action where required, excluding malevolent error. I believe ASME has a different definition for malevolent error. And then human failure events is a basic event that represents a failure or unavailability of a component, system, or function that is caused by human action or inappropriate action. So you'll see this in PRA, event trees or whatever. You might have an HFE that then led to these systems having problems. So it's a little bit different there. I'll wrap it up there. My voice did pretty well, but I can kind of feel it starting to fade on me. I'll try to record the second half of this later today. And yeah, that'll be fun. So let me get this working here. Thank you all.